So to start, what I want to do is to explain this concept as we see it in the real world, and then we see how developers have implemented this concept in programming. So first, let's take the scenario of the iPhone 8 is coming very soon, and there are basically two major ways to buy it. You have seen how people buy it. What are these two ways? Online. Or on the shop. Yes. And in the first few days, when we do it on the shop, let's say we have an Apple store somewhere. What happens?
It's very crowded.
Very crowded. Long queues. So one way to get to your phone, to get to the phone, you basically queue up on that long queue, and then what you do? What do you do in the queue? You wait. Basically, you are missing your courses, other important things in life, and you are basically blocking yourself in that queue until you get your turn, and then finally you get the phone and you get it at your hand. And so this is one way of doing it. So what's the advantage of this way? You get it. At a certain stage, you will definitely get it, and get it kind of one of the early people you will get it. But what is the disadvantage? You have to wait and waste your time. Maybe you miss your classes, maybe you miss some important things. And basically, you are blocking all your time to this task. Now, what's another way of doing it? Online. You just go online, and then what do you do online? You place the order, and then what happens? You wait. When you wait, are you blocking yourself? Or you can go on with other things in life? You can come to your classes, you can do whatever you need to do. And then, what happened in the future? What will happen in the future? Basically, someone from DHL or from a post office will knock at your door and say, here is the phone, here you are. So basically there are two ways of doing lots of things we do in life, two major ways. Either you block yourself to that particular task and wait there, do nothing else until you achieve that task. What we call this way of doing things, synchronous. And another way of thinking about it, if I want to communicate with somebody, there are two major ways I can do so. Either synchronous, I call them, and basically when I call them, I can't do anything else. Basically, I'm waiting on that line, and then I talk to them directly. That is synchronous communication. But here, both of us need to block ourselves, and we are during that conversation. And both of us need to be available. Now, the other way of doing it, in terms of communication, what's another one? Send an SMS, send a message, an email, send a WhatsApp message, whatever it might be. And in this case, I don't need to wait or block myself to this conversation. Whenever, later on at a certain time, I will get hopefully some reply. So this is basically the difference between synchronous and asynchronous. So if we go back to the phone example, if you queue up and get your phone, that's synchronous. If you do it online, that's asynchronous. What's the major difference here between the two styles? Blocking. So with synchronous, what happens? You basically block everything and wait for that task to complete before you move forward, before you proceed. With asynchronous, what do you do? Sorry? You initiate the task. You give some kind of way for that other person to come back to you. For example, in the case of the phone, what do you do? What do you give them for you to get your phone? The address. So you give them some ways for them to call you back or to send you back what you have requested. Okay? And then at a certain stage they will come back to you. Or when you send your SMS to your friend, what you give them? They kind of know the number, but basically you can even give them the number. Please send me this, or call me on this number, or send me this information on this number. So what you do is you don't block yourself. You can go on and do other things, but you have to give them some ways to call you back. When they are ready, when things that you have requested is ready, they call you back. Yes? So there is this concept of call back. When it's ready, they will call you. You initiate the request, you go on, do other things. When what you have requested is ready, what they will do, they will call you back. See, this is the difference between synchronous and asynchronous. So that's basically the concept. So this is buying the phone using a synchronous way, and this is buying the phone using an asynchronous style. Okay, so now what you have been programming so far, I'm sure all of it is synchronous. All of it. What I mean by this?
We run the code and we wait for the...
No, not only that. Your code is made up of what? Statements. Yeah? So what happens when a statement is being executed? Basically, the program is blocked there. If you call a function, what happens to the main program? It suspends and blocks and waits for the return to come from the function. Once you get the return, what happens to the program? You resume execution. This is what you have been using so far. Okay? But in practice, especially in web development and in enterprise applications in general, asynchronous programming is the dominant style, is the way people do things. Why do you think? It's very important programming style that you must master. This is not like an option. It's a must. What you will all really take from this course is the asynchronous program. It's a new style, as you will see shortly, with some nice techniques to do it. We will quickly see the evolution, and then we will see the latest way of doing it, which is very elegant way. In here, asynchronous programming, the main motivation for asynchronous programming is what?
No blocking.
No, thank you. No blocking. So basically, the users, in our context, your web users, you should never block them. You should never freeze the page and don't let them do anything. Which means anything that takes time, don't do it synchronously. You should do it asynchronously. Are you following? Give me an example of things that you can do, that you typically do on the web as a developer, and you should do it asynchronously rather than synchronously. An example.
The content and the style.
The content and the style. No, the content, you request a page, the content will be downloaded and rendered. But once the page is there, you might do some other things. Remember the example of you have a country drop down and you have cities drop down. I'm sure you have seen this on the web. So when you select a country, what happens to the cities or states? They get changed. So when you selected the country, what did the browser do? It's made a request back to the server. Say, oh, server, give me the states of this particular country. Yes? So when you do this, gives me the state of this particular country, should you do it synchronously or asynchronously? Asynchronously. If you do it synchronously, what will happen? What happens to the page? Will be blocked. The user will not be able to do anything until the state drop-down is filled. If you do it asynchronously, and let's say that request takes time, I can go and start typing in other text field or other place in the page, no problem. So don't block the user, that's the main. For the good user experience, asynchronous programming is a must. It's not like an option. You know, these companies are really, competition is very tense. Like if the user is unsatisfied with your page, they will not come back. And that's a big loss. So you try not to annoy them by avoiding By avoiding what? Blocking. And how do we avoid blocking? Using asynchronous programming. This is on the client side. On the client side, we do asynchronous programming to achieve what? To achieve what? Why do we use asynchronous programming on the client side? Better user experience, not blocking users, and giving them control. Leave the control to them. They can do other things while your page is doing some other task in the background. When the results come back, then you refresh the part of the page without annoying the user and blocking them. Yes? Now, on the server side, same idea is very, very useful. But what do we use the asynchronous programming on the server side for?
Answering requests.
Very good. Now, if we use synchronous programming to answer requests, what will happen?
Waiting for requests to be done.
Yes, so the server will block some resources. Let's say the server made another request to another server. So if you do it synchronously, the server will make the request and wait, block, until that response comes and to continue the execution. So instead, to be able to handle more requests, which we call scalability in technical terms, to handle more requests and to enhance scalability, programmers use asynchronous programming also on the server side. Not to give you better user experience, but to handle more concurrent requests. Is clear the idea of synchronous versus asynchronous? Let me give you the last one that you are familiar with. So, you check your dress to be fixed in the tailor. I'm not sure if you do that, or you just throw it and get another one. Anyway, let's say you gave it to the tailor. What are the two models you can do to do this task of fixing your dress? What are the two ways you can do it? With the tailor, what are the two ways? Talk to them, give them this dress, and then
Give him a drawing or something.
you wait for it to be fixed. No, it's cut somewhere and you want to fix it. So one way is just wait and block. Until it's fixed, you can't do anything, wait there, it's fixed and you collect it. Another way is to do what? Give them your number, and then when it's ready, what they will do? They will call you back to collect it. That's basically synchronous versus asynchronous. Is the idea conceptually clear? Now, we will now start seeing it how we do it in real life in programming. Okay, so what the idea here, I will try to throw you in this new area. It's very new to you, I'm sure. Now, you will go and practice more in the lab and then come back on Tuesday and then we polish it, finalize it. Okay? So, let me jump now to examples. Here is first an example. Let me just show you, and I will explain this later further next time. Just to show you. This is, for example, super fast. No problem. I click it, I get the reply. But this one, I might be doing some long-running process. So let me just refresh this page, and let's say this is a long-running. While this long-running is happening, you see here, everything is blocked. You should never put your users in this scenario where things are blocked. So how to solve this? Use asynchronous programming. This is just an example of what I mean by blocking. Okay, so the first thing I will show you now is the concept of asynchronous programming using callbacks. So the callback example is very simple and very straightforward and exactly matches the way we do it in the real world. You give somebody to do some task for you, you don't wait for them. Because your time is valuable, you have many things to do, you cannot afford to block yourself and wait there. You give them the task, and what else you give them?
There's something to come in.
Yes, typically a phone number. You stop at the mechanic, the first thing they will tell you, put the car and give me a phone number and go. Don't stay. There's no way I can serve you immediately. Okay? You go anywhere you go. You want to fix your dress, whatever you want to do. This is the model we do every time. And the reason why is for us not to be blocked and to move on and carry on other tasks. And when what we requested is ready, process is ready, we get called. So instead, I call and then I get called back. So that's the idea of callbacks. So callbacks is a way of doing asynchronous programming in JavaScript. And this applies to other languages that we are talking here about JavaScript. So let me give you an example. In here, in browsers, there is an API, there is a function called getLocation. And this getLocation can give you the coordinates of your location. Okay? So, now, anyway, don't worry too much about this. I want to focus on the concept, which is asynchronous programming using callbacks. So here, navigator is a built-in object in the browser, and it has a function called, it has an object called geolocation, which has a function called getPosition. When I call this function, typically when you in other contexts or in your previous programming experience, when you call a function, what do? You call a function and you wait for the return and you put the return in a variable. You have seen this, isn't it? I'm sure you have seen it. If you call something like add, so you say int sum, and you say add 1025. This is what you are used to. This is synchronous call. I call you, add, do the work, don't tell me come back, I am waiting for you. Do it and give me the result, and then I put the result here. In asynchronous programming, do I do this? No. In asynchronous programming, when I call an asynchronous function, what do I pass to it? Maybe I pass to it some parameters, plus, sorry? Headers, no.
Something that
Yes. I give it as a parameter, a function. That function I called, it will call that function once it's done its job. So basically, I will give it a callback function. I say, do your work. When you are done, what you should do, call me back using this function. Yes? So have a look at this example. So this is an asynchronous function. When I call it, I give it another function. What's the name of this function? ShowPosition. What does it receive? The position. This is the coordinates, basically the latitude and longitude. And I'll take this position and display it on the page. So basically, how this works, I call this function, get current position, and what do I pass to it as a parameter? Another function. What do we call this function I pass? It's called a callback function. And what's the idea of this callback function? That this gets current position. When it's finished its work, what it will do? It will call this function I pass to it as a parameter. Okay? I know in the beginning it's a bit confusing, but gradually we'll get used to this. And through examples, I show you further examples. So let me just run this just to show you what it means. Okay, so here, get location. So this, I got the location, but I didn't wait for the location. I made the call and give the call a callback. And when the location was extracted, this callback function was called. Yes? Okay, so for any long-running operation, if you want to call another server, let's say another resource, another page from your page, because this could be a long-running, because the page could be on another server in another country. It might take a long time. So you always do it in asynchronous way. You don't do it in synchronous way. So now this is on the client side. These examples I'm showing you is on the client side. Let me now show you an example of asynchronous programming on the server side. Remember, we will be using JavaScript both for the client and on the server. So on the server, let me show you here. So reading files. Reading files, when we read files, we heavily use asynchronous programming. Because a reading from the disk, it could take a long time. So we don't want to block our program. We basically use asynchronous programming before I explain this, let me explain one more thing so you can understand what's going on here. The first thing I want to explain, you know, outside the browser, how do we run JavaScript outside the browser? What do we use? We use this framework or this Node.js. So for you to run this program, you have to install Node.js. Okay? Now, this Node.js has Java runtime, so a Java engine that can run JavaScript files. Okay? Now, this Java runtime is so popular, and it has so many other packages and libraries that you can use. So when you think of some functionality that you want to add, let's say reading or writing to a database, you don't need to start from scratch. There are so many packages out there that you can make use of. And there are some packages that come with Node.js itself. Yes? So, I will explain those packages. We will explore some of the packages as we move forward. But for today, one of the packages we might be using, there is a better one, but for this example, I'm using this package called FS, which stands for File System. So, for me to use package, I say require. It's similar to Java when you say import. Remember, like you have some jars that are some classes and some interfaces. Before you use them into your program, you have to import them. Yeah, you are familiar with this. So same thing here. Node.js comes with a lot of packages. For you to use them, you first require, which is equivalent to import in Java. So in here I'm saying I want to use this FS package, which stands for File System. So first I will say let and require FS. And this FS has a couple of functions, very useful functions to read and write files. All right, so here it is. So here I have a file called student.json. Have a look at this. Here is the file located here. This is student.json. The code you see, this data you see here, the format is called JSON, JavaScript Object Notation. Remember we've seen how to create objects in Java? So you can put those objects in a file, in a text file, and you can read and write them. So you can convert from an object to a string and from string to an object very, very easily in JavaScript. So in here, this is basically a set of an array of objects. You see what's going on here? So it's an array of objects. I have many students here. Student 1, student 001, 002, and this is the first name, last name, gender, the courses they are taking. So many students I have here, yes? So my goal here is I want to read this from a file and just display it, yes? Okay, so let me show you reading using callbacks. So I go to this FS package and I say read file. Okay, and then I give it as a parameter which file do I want to read. So the dot stand for current folder, go down to the data subfolder and go down and you will see there a student.json file. I want you to read it, but a read file, is it a synchronous function or asynchronous function? It's asynchronous. This one is synchronous. I call it, wait for it, and get the reply and put it in a variable. This one is asynchronous. So if I want to use it, what should I do? Give it a callback function. That's basically the idea. If the function is asynchronous, I cannot call it and wait for it. If it is asynchronous, I have to call it and give it a callback function. What this callback function is used for? After which one finishes? Yes. When a read file finishes, what it will do? It will call your callback function. Yes.
We are still waiting for the read file function.
No, you will see. We are not waiting. You will see. Okay. No waiting. Exactly the same as your Taylor experience. You give it the address, you give it the phone number, and you go. And then later on, that Taylor, when they finish, they will call you back. Exactly the same. No difference
So
whatsoever.
the rest of the code is running during the reading part?
When I do read file, let's say I call this fetch student. When I call fetch student, I don't block. It goes. It will keep doing other tasks. When a read fetch student is finished, it will do whatever the callback is supposed to do. Okay. So what I'm doing here, I am passing a function. Have a look at this. This hopefully is not too scary now because function can be passed as a parameter to another function. You already seen this. It's nothing here very scary. Now this function takes two parameters, error and data. If there is some error when reading the file, you will find it in this error object. If the reading was successful, you will find the data that has been read from the file in the data parameter. Yes? Now, inside this function, what I'm doing, if there is an error, I will give it back to whoever called this function. Okay. If there is no error, I will get the data and convert it to an array of objects. So how do I convert from a string? Remember, when I read from a file, what do I get at my end? A string. How do I convert a string to objects? Using this very simple object called JSON parse. And this will convert this string to a list of student objects. And then I am here interested into one particular student, so I filter to get that particular student. And then I basically send it back to the caller. So let's put this. Okay, this one is just what I'm doing here. The student has a password. Have a look at this. Don't worry too much about it, it's not very important. The student, do we have password? No, because I changed it. All right, so this is good. Delete. You can delete a property from an object if you wish. This is another dynamic feature of JavaScript which I didn't show you last time. If you have an object, if there is some attributes you don't need, you can delete them. So that's what delete is for. But I don't have password there anymore, anyway, so let me just keep it simple. So let me explain this one more time. So fetch student, is it a synchronous function or asynchronous function? Asynchronous function. So when I call fetch student, what do I pass to it? Two parameters. Which student you want, and give me a callback to call you when I'm ready. Okay? I know it is very new programming style, but you will get used to it as we move forward gradually. Okay? So fetch student itself calls another asynchronous function. And this asynchronous function happens to be read file. So it reads the file. If there is an error, I'll just pass it to the callback function. If there is an error, for example, this tailor is not able to fix your dress, they will call you and say, pick up your dress is unfixable. It's an error. So it will give it back to the caller. If there is no error, what it will do, this callback function, it will basically filter to get that particular student you are looking for, and then return it to the caller. So this is exactly like the caller, the tailor calling you and saying, come and pick up your dress. There is no error, so I pass null, and this is the fixed dress, or this is in our case, this is the actual student. Okay? So this is the pattern that in Node.js programmers use. When you pass a callback, when your callback is called, usually takes two parameters. One is the error, if there is any error, and the other one is the actual results. So either one. So always when you're in a callback, you always check. If there is an error, the reason why they put error in data so you don't ignore errors. Life is not always perfect. There are always things that go wrong. So that's why when you are called back, not always good news. Okay, when this mechanic callback saying your car is unfixable, all you need to do now, take it, break it into part and try to sell it in Qatar. That's all you need. Okay? Or good news, come and pick up your car. So that's basically the idea. So if you understand this, the rest is the same. So this is just giving you more examples of callbacks, callback functions. Okay, let me now show you how are we calling the fetch function. Remember, the fetch is itself an asynchronous function. By the way, if you use an asynchronous function inside a function, that function also becomes asynchronous. Okay? So for example, I'm just, okay, can I think of an example? Okay, I can't think of an example. Let me just confuse you now, this is enough. This is a fetch, okay? The way I call it, I give it the student's ID that I want to fetch, and because it is asynchronous, what do I give it as well? A callback function. So a callback function always takes two parameters, an error and the object that you are expecting. So here I'm ignoring the error and hoping that everything goes well. And basically I receive the student and I am converting it to string and putting it into the console. How do I convert an object to a string? Again, JSON.stringify. So JSON.parse converts from string to objects, and JSON.stringify converts from an object to string. Is clear so far? Okay, here is another one. Here I'm saying get student, and same thing. Here the difference is, let me show you what fetch student does. What get student does. Have a look. Have a look at this. So what I'm doing here, have a look at the student. Here is the student. Okay. You see here I have these courses IDs here. So a student has courses that they take. This is not very meaningful. So I want to convert these numbers into the actual course name and the actual course names. So what I will do after I read the student, I'll go and read another file, which is the courses, to get the course details. So I have another file here. Have a look. Here is the course. So there is a CRN, and there is the course details. So, for example, 107 is General Engineering 107, General Skills and Ethics. So there are two steps. If I want to get the full details of the student, two steps. First, I read the student details from students, and then I read the course details for the course file. Okay. So here it comes the difficulty of using callbacks. So no longer, because in synchronous programming it's very, very easy. I call the students, I block, and then when I get the students, I get the courses of the students, and then it's very easy to do. But with asynchronous, it's much harder. It's much harder to do. So for example, you want to fix that address and then take it to the on. So basically you have to coordinate. So what you do is, you say, okay, you give the Taylor callback, and then when they call you, you then pass that, you basically receive that address, and then you give it to the what they call it? Like iron place? Sorry? Laundry. Okay. You give it to the laundry, and then same thing will happen. Then you will not block and wait. You will call, you will give it to the laundry and give the number, and then when it's ready, they will call you back. So, but there is some kind of dependency. You first need to receive the address, then you do another call. So same thing here. I first have to receive the student, and then I use the student to get the courses of that student. Yes?
So this is synchronous.
Sorry?
This is synchronous. We are waiting for...
No waiting. So basically, I'm not waiting. So I gave the address to the Taylor, I'm not waiting. I come to my class, I do shopping, do whatever I need to do.
But I can't execute this function if I can't get the return.
Okay, very good. So what will happen when I get called back? Then I will do another action and call, and basically take, in our scenario, take the dress to the laundry. So I'm still not blocking. There is no blocking here. And basically, I carry on. Blocking means I cannot do anything else. Everything is blocked until. So for example, this is blocking code. Code that is in here cannot execute until this comes back. Okay? So the way we do this asynchronously is, let's have a look at this. So first, I fetch the student and give it a call back. When the student hopefully comes back, I will fetch the courses. And when the courses come back, I will give them back to the code. So this is how I compose, how I put together multiple asynchronous functions. Okay? So these things you can only really appreciate or really understand by really doing. That's what you kind of do in the lab. So in here, composing asynchronous functions, or making chain of asynchronous functions, is very hard. And if you do it, your code will be growing this way. Your code will be growing like as a pyramid. And basically, callbacks are one way. So asynchronous function is done by, there are many styles or many ways of doing it. The first way that developers have invented to do asynchronous programming is using callbacks. Another better way that we will further emphasize in our course is called a promise. So basically, when you study this subject, there are three ways you can do asynchronous programming in JavaScript. Callbacks, you just need to be aware of them because we are not going to emphasize on them because there is a better way of doing it. This is in JavaScript 2015, there is a new way of doing it using what is known as promises. Now in JavaScript 2017, there is even a better way of doing it called async and await. Okay? So we still need to kind of study this because they build on each other, but ultimately, once we understand this, this is the style of programming we will be using. But for you to get here, you have to understand the evolution of this. And also you have to understand this because in real life, you will find a mixture of these techniques used. And you need to understand all of them. But if you are writing something new from scratch, which style you will go with? Async await as a style of doing asynchronous programming. So let me just show you, last thing I want to show you is the concept of a promise. So a promise, like in the real world, I kind of, somebody promises you something. And then you take that promise, and when it materializes, when it becomes true, you basically carry on some other activities. So function, instead of returning a value, it can return you a promise. And then when the promise gets resolved or become real, you can do some action based on that. So let me show you how these promises look like in JavaScript. Okay. All right, so let me show you get student. All right. So here is an example. So here in the web browser, if you remember, in the browser, in many scenarios, you might have, for example, two drop-downs that are dependent on each other. I gave you the example of country and states, or cities of that country. So what the browser will do, when you select a country, it will go and get the cities of that country. And it will do that asynchronously in the background. It will not do it synchronously and block the browser. So to do this asynchronously, JavaScript comes with a function called fetch. So fetch, you give it a URL from where you want to fetch the data. In this case, I want to get it from the same website, from the data subfolder, student.json. And fetch returns me what is known as a promise. Fetch is not synchronous. When I say fetch, it's not like add, I block and get the result. It's asynchronous. So what I do here, when it's realized, I say here then, in the future, when I get the students, I will take the response and convert it to JSON.
Okay. Is it like we are sending a callback function and the callback function has the same code that the response user?
Okay, similar to a callback function, but just the syntax. This is a kind of callback function. But instead of passing it as a parameter to the fetch, I use this keyword here, then. So this is a promise. In the future, you will get some data about the student. Then, when such promise becomes real, I will take it and convert whatever I get to JSON. Okay? Have a look at this. This is the last thing I will show you. This one is also an asynchronous function. It returns me this is a promise. So a promise built on another promise. So for example, let's say a bank or somebody wants to, let's say, take a loan to buy some, let's say, a house. So they will go to the bank, and the bank will give them a promise to lend them money. And they use that promise to go and buy the house. Okay? And then when the money comes, it will go to the house owner. Okay? So it's kind of a bit similar here. So this get student is also returning a promise. And then here I call it, I say get student. Then when in the future the value becomes available, I say that those objects are displayed. So it's kind of similar to the concept of callback. But in terms of what promises allows us to do, they allow us to compose multiple promises together. So, of course, I will explain this in much more details later on, but let me just show you the final, how it looks. This is what promises really makes it easy to do. I know it might not make a lot of sense at this stage, but what I have here is I call get student. When in the future I get the student, I will call get courses. Then, when in the future I get the courses, I will get the instructors of those courses. And then when in the future I get these instructors, I will display. So it's kind of chaining these promises together.